Hello my dear students, a very warm welcome in today's session. In today's session we are going to continue our chapter number 4, that was atomic structure, with the part number 3. We have covered 2 sessions of this chapter. In the previous 2 sessions we have covered almost all the important topics, and today we are going to continue with some more important topics. But before doing that, we are going to do a quick recap of the previous 2 sessions. You can see on the screen, we have covered a lot of topics in the previous 2 sessions. The first topic that we have studied was basics of atomic structure, that what is an atom, is it divisible or indivisible, and what are the perspectives of scientists in the previous ancient history. Okay, and then we have studied the ancient views of atomic structure. We have also studied ancient views of atomic structure according to Maharshi Kannad, and he gave the name to atom as Anu, and the subdivisible particle or the subatomic particles of atoms were called as Parmanu. Okay. Then we have studied Dalton's atomic theory. In this theory, we have studied 4 to 5 postulates in which Dalton stated that atom is indivisible particle and it cannot be divided further. He also stated that the atoms of same elements look alike and atoms of different elements are different from each other. These were the postulates that he gave, and the fourth postulate that he stated was that atoms of different elements combine to form a compound in a fixed ratio. But after that, we have studied modern atomic theory, which contradicted atomic theory of Dalton. Okay. In the contradictions, we have studied that according to modern atomic theory, atom can be divisible into subatomic particles, that is electron, proton, and neutron. But Dalton stated that atom is indivisible. So this was the first contradiction that we have studied in the modern atomic theory. The second contradiction we have studied was that atoms of same element can look different. But when we are talking about the case of isotopes, and we know very well that what are isotopes. Okay, there is no need to explain this because we have studied this about in previous 2 sessions, and then we have studied the correlations between Dalton's and modern atomic theory. Because we have stated the contradictions, there were some correlations also between Dalton and modern atomic theory. Those correlations were what? That in the Dalton's atomic theory, it was stated that atoms of different elements just combine themselves to form a particular compound. Okay, and this is the point that was stated in modern atomic theory also. So this was the correlation between modern and Dalton atomic theory. Afterwards, we have studied the subatomic particles of an atom, and the subatomic particles were electron, proton, and neutron. But who discovered electron, proton, and neutron? We have studied those discoveries as well. In that, we have studied discovery of cathode rays, which was done by William Crookes. Okay, and then after that we have studied discovery of electrons. But what we have studied in discovery of cathode rays? We have studied that there was a discharge tube taken by William Crookes, okay, and he did what? He just removed the air from it, and then he applied 2 electrodes on the both ends. The electrode that was connected to the negative end was called as cathode, and the electrode that was connected to the positive end, that was called as anode. Okay, and he saw that when he applied the voltage, in the discharge tube, he saw what? He saw a green glow behind the anode. Okay, and that glow, he observed that glow, and he concluded that because of the cathode rays, because of some particles that were emitted from cathode electrode, that glow was observed. And that's why he stated that there were some particles that were emitted from cathode, those are striking behind the glass of anode. So that's why he stated the discovery of cathode rays. Afterwards, who came? J.J. Thomson came, and he discovered electrons. He discovered electrons, but how? He studied or he observed the characteristics of cathode rays by applying electric and magnetic field, by applying some objects in the path of cathode rays, and he stated that cathode rays consist of negatively charged particles because when he applied electric field, he saw that cathode rays just deflected towards the positive terminal. And whenever any particle is deflecting towards positive terminal, it states that those particles consist of negative charge. So that's why he stated that cathode rays consist of negative charge, and those negative particles were called to be electrons by Sir J.J. Thomson. After that, we have studied discovery of protons that was done by Goldstein, and he studied what? He just used a perforated cathode ray tube in which he used perforated cathode, and then he saw what? He saw some particles were emitted from anode to cathode, and after just emitting of the anode rays or the particles that were emitting from anode, he saw a glow behind the perforated cathode. That's why he said that there were some particles, those were emitted from anode. After that, we have studied Thomson's model of atom, in which J.J. Thomson gave a diagrammatical view of the atom, of the structure of atom, in which he says that the positive charge was distributed all over the atom and negative charges were in the circular cloud. Okay, and this model was also called as plum pudding model. Plum pudding model. Afterwards, Rutherford come and gave alpha scattering experiment. In this experiment, we have studied that he used an alpha particle source, that was radium or lead, and from that source the alpha particles were emitted, and then they just bombarded on a metallic sheet of gold thin foil. Okay, he just bombarded the alpha particles on the foil of gold, and then he observed what? He observed that some particles were deflected with some angle. Most of the particles went straight, but some of the particles were those, we can say 1 in 2000, which deflected back on the same path, or they just deflected themselves with an angle of 360 degrees. Okay, and after these all observations, what he stated that an atom, because he bombarded those alpha particles on the atom of, or we can say on the foil of gold. Okay, so that's why he stated that an atom as a whole has a lot of space vacant in it. Okay, and there is a positive charge that is concentrated in the center. But how he stated that? Because from the center the alpha particles were deflected back, because alpha particles have positive charges, and if they are deflecting back from the center of the atom or the center of any object, it means that those or that center has some sort of positive charge, because positive can only reflect positive charge, or we can say oppose positive charge. Okay, so these were the points, or these were the topics that we have discussed in the previous session. Now we are going ahead with today's topic, that is on your screen, Rutherford's nuclear model of atom. After the Rutherford's scattering experiment, he proposed the nuclear model of the atom. Okay, after his experiment, he proposed atomic structure, or we can say the structure of atom. Okay, on the basis of his experiment, Rutherford put forward the nuclear model of the atom. The model describes the structure of the atom as follows. And according to his model, what he described, that there is a positively charged core. There is a positively charged core, or we can say center, in the center of an atom called the nucleus. He said that there was a positive charged core in the center of the atom, and he named it as nucleus. You can see here the image. The positive charged core is known as nucleus. He gave the name it as nucleus. After that, what he stated, nearly all the mass of the atom is concentrated in the nucleus. He also stated that nearly all the mass of any atom is concentrated at the center of the atom, that is in the nucleus part. Okay, so this was the first point. He just described about the structure of atom he proposed. After that, he also described the second point, that was the electrons revolve around the nucleus. He stated that electrons revolve around the nucleus in well-defined circular paths, which were called to be orbits, and these were also called to be shells. Okay, the second name for orbits were shells. So he stated that the electrons, you can see The blue ones or the purple ones are electrons. They are revolving around the nucleus, the center of the atom. Okay, they are revolving around the nucleus. He stated that, and they are revolving on a circular path that is known as orbit, that, or we can say shell also. Hence, this model is also called the planetary model of the atom. This model was also called to be the planetary model of the atom because it was a look-like structure as the solar system. That's why it was called to be planetary model of the atomic structure. Okay, now moving ahead, we are going to study the third point that was stated by him about the nuclear model of atom. The third point says that since the atom is neutral, because we know that any atom of the particular element is neutral in itself. Okay, so the number of electrons, negatively charged particles, electrons have negative charge, is equal to the number of protons, positively charged particles in the nucleus. What he stated that we know atom is a neutral in itself. Atom is neutral in itself. What does it mean? That atom has a charge of 0, and it is only possible when the number of protons will be equal to number of electrons. Because if we have number of protons equals to number of electrons, then they will cancel each other, or they will cancel the charge, they will minimize the charge. Okay, and that's why it will tend to 0, and then we can say the atom is neutral in its own state. You can see here that we have nucleus in the center, and we have electrons, they are revolving around the nucleus or the positive charge with a path that is known as orbit, and the nucleus which containing positively charged protons. Okay, you can take a screenshot if you want to. Now we are going to study the next topic that is on your screen, which says Bohr's atomic model. After Rutherford just gave us the nuclear model of atom, then Niels Bohr, he was a Danish scientist who came, or Danish physicist, who came and gave us the atomic model. You can see here the Danish physicist Niels Bohr further developed Rutherford's model. He developed Rutherford model because he saw some type of defects in Rutherford's model. He just developed Rutherford model. In 1913, he proposed his atomic model. In 1913, he proposed his atomic model according to Bohr's model. Now, according to Bohr's model, he stated what? He stated that electrons revolving around the nucleus. We know that Rutherford told us that electrons are revolving around the nucleus in a circular path which were called to be orbit. Okay, so electrons revolving around the nucleus occupy particular orbits. Each and every electron around the nucleus will occupy particular orbit, and which are also called shells. I have already told you that those orbits will be also known as shells. He labeled the shells as KLMN, starting from the innermost shell. He labeled those orbits, those paths, or we can say those shells as KLMN, starting from the innermost shell. This one, innermost shell. Okay, you can see here, this one is K shell, then L, then M, and then N. This was the Bohr's atomic model. Okay, this is the nucleus which consists of positively charged protons. Okay, and these 4 are orbits, or we can say these 4 are shells, and these 4 shells were named as KLMN according to Niels Bohr. Okay, further moving, we are going to study the second point of his atomic model, that is each orbit or shell is associated with a fixed or definite amount of energy. He also stated that each orbit and shell has a fixed amount of definite energy. Okay, and hence these shells are called energy levels. That's why he also named these all shells as energy levels, because he concluded that each orbit or shell has a particular definite amount of energy. Okay, the energy associated with energy levels increases as we go further away from the nucleus. Whenever we are just going away from the nucleus, then what happens? The energy level increases. That is, amount of energy of K is less than L, is less than M, and is less than N. So that's why we can say the energy level of nth shell is greatest, okay, or we can say is highest, and the energy level of kth shell is lowest. So whenever we are moving from innermost shell to the outermost shell, the energy level is increasing further. Okay, this was the second point which was proposed by Niels Bohr. You can take a screenshot if you want to. Now moving further, we are going to study the discovery of neutrons. Now Rutherford gave us the scattering experiment. After that, he proposed the nuclear model of atom also, and after that Niels Bohr also gave his model of atom. But now we are going to study the discovery of neutrons, as we have studied discovery of protons and electrons. So Rutherford concluded that virtually all of the mass of an atom is concentrated in its nucleus. What he concluded, that all of the mass is concentrated in the nucleus of a particular atom. Since electrons have a negligible mass, because we have studied that electrons have a negligible mass, it was believed that the entire mass of the atom was because of the mass of protons. He believed, or we also believe, that the entire mass of the atom was because of the mass of protons, because we have studied that in the nucleus there were positively charged particles which were known as protons, and around the nucleus there were electrons, but we have considered the mass of electrons negligible. So that's why we can say the whole mass of the atom will be contributed by the number of protons present in the nucleus. Rutherford found that except for a hydrogen atom, he found what? He discovered that except for hydrogen atom, the atomic masses of other elements were more than the total mass of protons. In the case of hydrogen atom, what he observed, that the total mass was equal to the number of, or we can say mass of protons. But other than hydrogen, he found what? That other than hydrogen, in the other elements, he found that the mass is not equal to the mass of total mass of the number of protons. He found what? That therefore in 1920, what happened? That therefore in 1920, Rutherford predicted the presence of another subatomic particle in the nucleus of the atom. What he predicted? Because of that, he got the mass of the particular atoms of different elements excepting hydrogen. He found that the mass of particular atom is more than that of the mass of number of protons, total number of protons. Okay, so that's why he concluded that there is another subatomic particle which is contributing to the mass of the atom. So it led to the discovery of neutrons. Afterwards, what happened? In 1932, James Chadwick came and he did what? That he established that an atom consists of subatomic particles, that is electrons and protons. He saw that electrons and protons are the basic subatomic particles. Okay. Afterwards, electrons have negligible mass. We know that very well. Hence, the mass of the atom is concentrated in the nucleus, which should be equal to the mass of the protons. He also stated, and we also know about, like Rutherford also stated, that the mass of the whole atom is contributed by the mass of the protons, because we have taken mass of electrons as negligible. But what happened further? But in case of helium, except hydrogen, I have already told you that Rutherford explained that excepting hydrogen, in case of other elements, what happened? But in the case of helium, there are two protons, okay, in its nucleus. When we take the case of helium, there are two protons. We know that very well, because the atomic number of helium is 2, and that's why we can say the number of protons is also 2. We will study it further. But for here you have to consider this. Okay, so in its nucleus, and hence atomic masses should be equal to twice the mass of each proton, and that's why we know that the mass of proton, total number of protons, is equal to the mass of the whole atom. It contributes to the mass of whole atom. So that's why what should happen here, that the mass of the atom should be equal to twice of each proton. That means 2 into 1.008, that is the mass of proton, a particular proton. But its atomic mass is calculated experimentally and found to be 4.033. This was the exception. You can see here very clearly that when it was calculated experimentally, the mass of helium, it was found to be 4.003. But it should be 2 into 1.008 according to the concept. Okay, so that exception is found by James Chadwick. That's why he concluded what? After this all observation, he concluded that he said that it was therefore proved that in the nucleus of the atom are present particles which possess no charge. So he concluded that there were some particles present in the nucleus of the atom, those are not possessing any charge, but have the mass almost equal to that of the protons. But they have mass almost equal to that of the protons. We have seen previously. Okay, and the second point that he considered, this confirmed the existence of the neutron, and that's why it was considered that there was a subatomic particle obviously in the nucleus of the atom, other than proton, found to be as heavy as the proton. Protons and neutrons are together known as nucleus, and we have called them, or we gave the name nucleons to protons and neutrons in the combined form. Okay, so this was what the discovery of neutrons about, and James Chadwick just discovered neutrons. We have studied almost all the points about neutrons. Now we are going to study the properties of neutrons. You can see on the screen, we have the properties as well. Neutrons are present in the nucleus of an atom. We have studied. Okay, the atoms of all elements contains neutrons except the hydrogen atom, because when Rutherford was experimenting, he saw that hydrogen has the mass equal to a proton. So that's why he declared, or he said, that there is not a presence of neutron in the nucleus of hydrogen. But the points, the properties what we have to consider after the after the discovery of a neutron, that a neutron carries no charge, that is, it is electrically neutral. It carries no charge, basically. It has no charge. Okay. The second thing is what? The mass of a neutron is slightly greater than the mass of a proton. It's very bit, or we can say it's little bit, slightly greater than the mass of proton. The mass of a neutron is 1.675 into 10 to the power minus 27 kg. You have to just consider it. Now, moving further, we are going to study the nucleus and the extranuclear part. Till now, we have studied about the electrons, protons, neutrons, their properties as well and their discoveries. But now we are going to study the nucleus and the extranuclear region. Okay. So as you know, an atom consists of three fundamental subatomic particles, that is electrons, protons and neutrons. But structurally we have also studied the presence of electrons, that where are electrons situated. Now what you have to understand, that an atom is divided into two regions, the nucleus and the extranuclear region. So the nucleus consists of nucleons, and in which there are protons and neutrons. And when we talk about the extranuclear region, it has electrons. They are revolving around on a fixed path, which is known as orbit or shell. Okay. So moving further, we are firstly going to consider the first part, that is the nucleus. So in the nucleus, there are points on your screen, that the nucleus of an atom consists of protons and neutrons, elaborated previously. The protons and neutrons are collectively known as nucleus. We have also studied this. Almost the entire mass of an atom is concentrated in the nucleus, since electrons have negligible mass. This point should be noted, that almost the whole mass of an atom is concentrated in the nucleus, because we consider the mass of electrons as negligible. Okay. The positive charge of the nucleus is due to the protons only, because neutrons have no charge. Okay, they consist of no charge, as neutrons carry no charge. That's why the positive charge on the nucleus is just because of the presence of protons. Okay, now moving ahead, we have to consider some more points about the extranuclear region, the region which is out of the nucleus, or we can say which is outside of the nucleus. This region, this particular region, and just highlighting it, this particular region. Okay, this is the region which is known as extranuclear region. Now you can see that the first point here says the extranuclear region of an atom contains the electrons that revolve around the nucleus of the atom in definite orbit. So the extranuclear region consists of electrons, and they are revolving around the nucleus in particular orbits. Okay, in particular paths. Those are known as orbits. In an atom, the number of protons inside the nucleus is equal to the number of electrons. So whenever we are talking about any atom of particular element, the number of protons inside the nucleus will be equal to the number of electrons revolving around it. Okay, hence an atom is electrically neutral, because we know that atom is electrically neutral. That's why we know very well that the number of electrons will be equal to number of protons. Okay, moving ahead, we are going to study the final table about electrons, protons and neutrons, and the locations and the symbols as well. You can see here the locations, symbol, mass and charge of the electrons, protons and neutrons are summarized in following table. You can see the table on your screen. Okay, so the particle is electron, the first particle is electron, and the symbol for electron is E or E negative. Okay, the charge on the particle is -1 unit, or the particular charge, specific charge is -1.6 into 10 to the power minus 19 coulomb. When we talk about the mass of electron, it's 9.11 into 10 to the power minus 31 kg. Okay, and the location where it is situated in the atom, it is situated outside the nucleus, revolving around the nucleus in the particular path. Those are known as orbit. Now the second part is proton, or the second subatomic particle is proton. Its symbol is P or P plus also, and the charge on proton is plus 1 unit, or the specific charge is plus 1.6 into 10 to the power minus 19 coulomb, and the mass of the particle is 1.675 into 10 to the power minus 27 kg. When we talk about the location in atom, where it is situated in the atom, it is situated inside the nucleus. Okay. After that, the subatomic particle is neutron, and its symbol is N. Charge is 0, because we know very well that it has no charge, and that's why the mass is here 1.675 into 10 to the power minus 27 kg, almost equal to proton. It's not equal to proton, it's almost equal to proton, because it's 6 sometimes. We have taken it 6. Okay, so, and the location where it is located in the atom, it is located inside the nucleus. Okay, so this was the table. You can take a screenshot of this. So till now we have studied some more important topics of this chapter. In the next part, or the last part, we are going to end this chapter with some last topics of the chapter, the electronic configuration, which is remaining behind. Okay, and after that we are going to discuss the exercise as well. Till then you have to just keep revising. Take care of yourself, and thank you. Bye bye.